Alright, so to start reviewing these topics, we want to look at graphing linear equations. We know our standard form is given by ax plus by equals c. And those a, b, and c letters are just representing numbers when you look at linear equations. So we want to use the standard form to figure out if the following examples are linear. So if we look at this first example, example 1, we have y equals 3 minus x. We want to see if we can get it into that standard form. So if I add my x on both sides, now I have x plus y equals 3. So this looks very similar to my standard form. Actually looks exact, so this equation is linear. Now I want to look at this second example. Example 2, I have x squared plus y squared equals 16. And I want to figure out if that is linear by looking at my standard form. Now it looks similar, but my x and my y variable are squared, or raised to the second power. So this one is not linear. The next topic we're going to review is solving for a solution to an equation. So a solution is also called a root. They mean the same thing. And it is the zero of a function, so where that function equals 0. Remember, that value is located at the x-intercept on a graph. Alright, so in this first example, 14x plus 5 equals 61, I want to solve for my x value. So I'm going to first subtract the 5 on both sides. I'll be left with 14x equals 56. Then I'm going to divide by 14, so my x equals 4. So that is going to be my root, my solution to this equation, 14x plus 5 equals 61. So when I plug in that 4, it's going to be equal to 61. So 14 times 4 plus 5 equals 61, and 61 equals 61, so that works. My second example, I have 5x minus 20 equals 0, so I want to find what value for x that I plug in is going to make this equation equal to 0. So I'm going to go ahead, and add 20 on both sides. And simplify, so I'm left with a 5x equals 20, and my last step is to divide by 5. So I'm left with x equals 4, and my answer will be C. So when I plug this root and this solution back into my original equation, so when I plug it in for x in this equation, it's going to equal 0. Next topic is my rate of change. So I find my rate of change by the change in y over my change in x. So first I'm given this table of balloons and balloon costs. I want to figure out which one is my x value and which one is my y value, so I can figure out my change in y over change in x. So my balloons are going to be my independent variable, or my x, and my cost is my y, because that cost is dependent on how many balloons we purchase. So if I look at the change in y, I'm going up by 2 each time, and my change in x is going up by 1. So my rate of change is going to be 2 over 1 or 2. Next thing we're going to look at is slope, which is very similar to rate of change. Same change in y over change in x, but here we're talking about points. So I have my x and y values. Remember, my x comes first, then y. So I want to find my change in y. So I have 3 minus a negative 3 over 1 minus 2. So this changes to a positive. I have 6 over 1 minus 2 is going to give me negative 1, which reduces to a negative 6. So my slope for these 2 points, for the line that passes through these 2 points, is a negative 6. Alright, let's look at this example 2 here. So I've got r comma 3 and negative 1 comma 2, and they're telling me the slope is 1/4. So I want to find what that r value is. So what I'm going to do is use my slope formula and plug in my change in y over my change in x, which is equal to 1/4. So I'm going to simplify this a little bit. So I have negative 1 over r plus 1 equals 1/4. And what I'm going to do is cross multiply. So I'm left with negative 1 times 4 gives me a 4. Negative 4 equals 1 times r plus 1 is the same as just r plus 1. Then I want to solve for r. So I'm going to subtract the 1 on both sides. So r equals negative 5. Alright, so next we want to look at direct variation, which is given by my formula y equals kx. Remember, the k in my formula is the same as slope. That k is the same as slope in a linear equation. And I have no y-intercept. So for this example, when y equals 12, when x equals 4, I want to find y when x equals 8. So the first thing I have to do is write a direct variation formula for this situation. So if I have y equals kx, I know my y value, and I know my x value. So I'm going to plug those into my equation. So 12 equals k times 4. And I'm going to solve for k. So I have 3 is equal to k. So this is my direct variation for this situation. Next, I want to find what the y value is when x equals 8. So what I'm going to do is use my direct variation formula that I just made and plug in that x value. So I'm plugging in 8. So 3 times 8 will give me y equals 24. So in this situation, when x equals 8, the y value is going to be 24 on your graph. Alright, here we're talking about arithmetic sequences. So I want to write an equation for the nth term in this sequence, 32, 35, 38, 41, and 44. Remember, my nth term equation is given by a sub n equals a sub 1 plus n minus 1 times d. So first thing I'm going to do is find my common difference, which is I'm adding 3. So d equals 3. Alright, I found my common difference, so what I'm going to do is use that, as well as the other information given, and plug it into my formula. So a sub 1, remember, is my first term, so in this sequence, my first term is 32, plus n minus 1 and I found my common difference is 3. So I'm going to plug in 3 for D. And I'm going to simplify this a little bit. Alright, so after I distributed my 3 and simplified this a little bit, my formula for any term in this sequence is given by a sub n equals 3n plus 29. Alright, last thing we're going to look at is proportional relationships. So remember, a proportional relationship, the graph of that relationship is a graph that passes through the origin. So my origin is at the point 0, 0. And if it's a non-proportional relationship, that means it's not going to pass through the origin. So if I take a look up here at these two graphs, I have A and B. So it looks like A is really close, but doesn't quite pass through that center of the graph, which is where my origin is located. So my answer is going to be B. B is the graph that is proportional because it passes right through that origin, that point, 0, 0. Alright, here are the answers to the review packet. If you take a look through these, if you need to pause the video to spend some time correcting, please do so. So here are numbers 1 through 11. And numbers 12 through 18.